Okay, for the last chapter of the textbook, we're going to take a look at limits. Now, for the limits is honestly your most foundational thing that you're doing in calculus. Okay? The idea of limits, there's two basic types of problems we're going to apply this to once we start using them. That's the tangent line problem and the area problem. Okay? So finding a tangent line and finding the area of something. So the problems will look in a very basic form, like this. Everybody should be familiar with this type of problem. You're given 32 inches of wire and asked to form a rectangle whose area is as large as possible. Determine the dimensions of the rectangle to produce that maximum area. Anybody know the answer offhand? This is like one of those they show at math, like middle school math competitions and stuff. 8 by what? 8 by 8. 32 inches of wire means, because honestly, anytime you have no other limitations, it's going to be a square to maximize area. Okay? So 32 means each side here has to be, well, divided by 4, so you get 8 by 8. The reason for this, and what we'll get into, the way you're supposed to do it, create formulas for it. The area for the rectangle is what in general? Length times width. And then the perimeter is given to me as 32. And what's the formula for perimeter? 2L plus 2W. Then, once you have that, this is the thing you don't know, so this is what you're going to use to solve for this. What do you want to solve for, L or W?
L.
So if I solve for L, that gives me 2L is equal to 32 minus 2W. Divided by 2, you get 16 minus W, right? So that's going to be my L value. So I'm going to plug that in. So I have 16 minus W times W. If I distribute that, that's going to give me 16W minus W squared. So what shape would that be if I graphed it? Parabola opening which way? Down. Now looking back here, what are going to be your x-intercepts of this parabola? Negative 16? Regular 16, yeah. 16 and 0. So if I draw a parabola opening down that hits at 0 and hits at 16, the idea is my area could be anywhere inside of this, or along this curve. Well, where it's going to occur is going to be halfway, right? It's going to be halfway between those two things, therefore, that's going to be 8 units up. Okay? And what would that maximum area be? 64. So you end up with a max area of 64 square inches, but it's asking for the dimensions, and the dimensions would be what? 8 inches by 8 inches. Okay? That's kind of problem this applies to, but then they're going to change it up so you're building this fence up against a barn or something, so it limits one side. So it's not just going to be a simple square. Later on, you'll get to the point where it's no longer a rectangle at all. It actually has curves involved. Okay? So, definition of limit, going back to, and we've used the symbol for limits before. The limit as x approaches c of some function is going to be equal to some number. Okay? So generalizing it out. So if I have a problem written like this, I want to use the table function on the calculator to estimate what the limit is. So what this means is the limit as x approaches 3. That doesn't care what it is at 3. What's going on as it gets closer and closer to 3? Almost what? At 3. What is it actually at 3? 12. Plug in 3, right? As this gets closer and closer to 3, this should get closer and closer to 12. But the reason is, if you actually look at the table, and I'm not going to make you punch it in for this one, I'll make you do it for the next one. But if you plug in 2.9, you're going to get 11.5. 2.99, 11.95, 11.995, like that. So logically, what is it on the other side for 3.001? 12.005, 12.05, and 12.5. The idea is, as you get closer and closer to 3 along that x-axis, your value for the overall limit, the overall function, gets closer and closer to 12. Yeah, so what? At 3 it's 12, right? Where this honestly gets used more often is something like this. Limit as x approaches 0. Well, what is it at 0? What is it at 0? It's not possible. You can never divide by 0. You can't take 0 divided by 0, right? Here you get 0 plus 9, so you get the square root of 9, which is 3. 3 minus 3. 0 in the denominator means it doesn't work. So what I want to do is I want to look at what's happening around there. Okay? So for this, I want to put in this equation. Everybody knows how to use the table function on their calculators? No. Okay, so put in the equation. Oops. Let's actually put the square root in there. Make sure you close out the parentheses on the radical after the 9, but you have parentheses around the entire thing, so the 3 is in the denominator. So it should look something like that. Okay? Now, if I graph it, nothing really weird looks like it's going on. It's just kind of a curve. But if I were to use the table, I'm going to go to second and table set, and I'm going to put in values here. So second in the window on your calculator. Okay? So I'm going to actually put my start at negative 0.01. And then I'm just going to increase by 1 smaller. So 0.001. Then table is where? Second graph. So I can see at negative 0.01, I'm going to fill that in as 5.998. Then if I go to negative 0.001, I get negative or positive 5.9998. At 0, I actually have an error, which we suspected. So if I want to find this one, what do I got to do with my table? Yeah. Go ahead and change. You can do the difference. Actually, I may even change the starting point. Negative 0.0001. Then back to your table. Whoops, I did one too many zeros.
Is there a way to just type it in this table and take you there?
No, not that I know of. So second table set, and then I'm just typing in this number. Negative 0.0001. I'm going to go up by something even smaller. Actually, you can see even then, these older calculators actually will give you flat out 6. And the newer ones, are you getting 6? What are you getting on the newer calculators? Oh, you are getting 6 in the newer.
If you go over to the 6 value.
Oh, okay, it will give you that. There we go. So it'll actually give you the 5.999. Anyway. So then if I go 1 past that, 1 past 6, you get what? Or 1 past 0, I should say, on the x. 6.00001. So this one's going to be 6.0001. 2 zeros and a 1. So in other words, looking at that, what value is it approaching? 6. Does that make sense? It's not actually, it's saying, what is this value at the limit as x approaches 0? Not what it is at 0. At 0, it doesn't exist, right? So this is saying, what happens if you get really, really close to that? Does that difference make sense? Good. So honestly, these problems end up being pretty easy, especially, honestly, I don't use the table much. The book talks about using the table, but I do something slightly different. Because if I have this function, and the limit as x approaches 2, well, does this function exist at 2? No. Plug in 2, the denominator is 0, it doesn't work. So, what I want to look at is instead, I would actually graph it, but then rather than using the table, I would use the graph. So I'm going to put in the x to the third. Make sure you either make this giant fraction or put parentheses on top and bottom, otherwise it will screw up. Now when I graph it, I'm going to look at what happens when the x is 2. So I'm going to trace this, and I'm going to go to 2. Well, 2, it does not exist, which we knew that. So then I'm going to look really close to that. 1.9. 5.61. 1.99. And you can get closer and closer to it. And you can even go to the other side of it. Well, what's it appear to be approaching? 6 again. So this one again is 6. Pretty easy? Okay. I got the ones where the calculator won't graph them as easily. So I can't use the calculator here. Find the limit of the function as x approaches 5. I can still graph it just by hand, and it does help me if I do. Okay? So, what does this graph look like? Piecewise function, we've done these before. So what's this mean? If I look at this, f of x is just what? Y. So it says y equals 1 if x is not equal to 5. So how do I graph y equals 1? Horizontal line at 1. But what do I got to do about this? Skip over it. In other words, put a hole in the graph. So draw a horizontal line. When you get to 5, literally just hop over it. Keep going. What about the other half of this? Y equals negative 2, x equal to 5.
Negative 5, you just do it down.
Yeah, there's a point. At 5, you go down 2. So this is what that graph looks like. So then what would be your limit as x approaches 5? 1. So the idea here, the limit, you would say it appears to be 1. Honestly, if you just put 1, that's fine. The technical answer should be that the limit appears to be 1, because it may be doing something really bizarre that you can't see at that level, but, yeah, if you just put 1, that's fine. We're not going to throw any equations at you that are horribly bizarre. Okay, so look at this. As x approaches 5, right? So as I go along this line, what's the value of this line right here? 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 At exactly 5, it jumps down to negative 2. But as you're approaching 5, either this way or this way, you have 1. So it doesn't care what's happening at that value, it cares what's happening immediately left and right of that value. Okay? Yeah, mathematically this stuff isn't too bad, it's just conceptually a little confusing at times. What about this one? Notice the instructions are a little bit different. This says it has no limit. What's that matter? Let's look at the graph of it. It's always going to be 1 or negative 1, right? When is it going to be 1? When x is a positive number. So we're up here at 1 here. At 0, well, it's not that. At 0, this thing doesn't exist, right? So it's going to be negative 1 whenever x is negative. So the idea is you actually have two different sort of like limits going on here. And when x is greater than 0, anywhere over here, your value looks like it's equal to 1. Anywhere x is less than 0, you have negative 1. Because those two numbers are different, then that implies that the limit does not exist. Oh, because you're dividing the same number by itself. So if you do 2 divided by 2, 3 divided by 3, 4 divided by 4, it's going to change when you're doing negative 4 divided by the absolute value of negative 4. Because that's going to be negative or positive, so it's negative. This one you can also just type in the calculator. Just put in y equals x over that absolute value of x.
How do you do absolute value?
Math, and then it's under the menu, under number, go to the right one.
Wait, why isn't the limit just negative 1?
Did the ABS?
Because the idea is you're approaching it from either side. It has to be, as you come in, it has to be approaching from that same value from both sides.
So you can't have two limits at one time for it.
Correct. For any given value you're approaching. Does that make sense? Okay. So, what about this one? Does this one exist? Well, go ahead and graph it if you're not confident what it looks like. Just y equals 1 over x to the 4th. What does it look like when you graph it? Line at 0, the spike in the middle? The spike actually comes to a point. Does this come to a point? No. Will those ever reach, actually touch each other? No. In other words, you have what there?
It's an asymptote.
You have an asymptote. Okay? So, is there a specific value that this graph approaches from both sides as x gets closer and closer to 0? Right, it's the same thing as the 2. The idea is there's no specific value. I mean, you might be able to argue that it's going to infinity, but that's not a specific number. It's got to be a hard, specific number. So this one, again, the limit does not exist.
So if we look at a problem like that, or what do we have with a problem like that? We just say
Potentially.
it doesn't exist.
You have to say why. Okay? Appears to go to infinity, goes to two different values, that kind of thing. Okay? What about this one? What would be the limit as x approaches 0 of cosine of 1 over x? Well, what does this graph look like? What's it look like? Make sure you put 1 over x in parentheses. Anybody? Just a straight line? Make sure you're in radian, like hit zoom trig. Because if you're in degrees, it will look a little skewed. Or make sure you're in radians if you're doing zoom standard. Well, I mean, basically your x value is throwing you off because it's going 0 to like negative 360, 360. Okay. Hit mode, go make sure you're in radians. Then hit zoom and go to zoom trig. Because it should not be a line. The newer calculators, I wonder if they're good. There's something weird there because there shouldn't be an asymptote. It's cosine of 1 over x.
Oh.
You're graphing 1 over x.
Me too.
Not bad.
Say again? Yeah, well, okay. So, does it look like it's approaching a certain value? Well, maybe, but it's a little bit above 0.
Yeah.
It's hard to tell, so I'm going to zoom in. That's kind of weird. So I'm going to zoom in again. Okay, let's try tracing this. If I put in something, 0, it doesn't exist, right? So if I put in .0001, so 4 zeros and a 1. Oops, I meant to hit trace first, sorry. So that's a negative number, right? Negative .999, so it looks like it's approaching 1, negative 1. So let's go even more details, 5 zeros and a 1. Well, now it's positive. 6 zeros?
It's starting to look like it's positive.
Now it's negative. Would this one have a limit? No, because what's going on here, this thing's actually oscillating between, I'll exaggerate it here, but sort of, there it is. Because this thing is oscillating, make sure I spell that right, between two values, then the limit does not exist. So that'd be like your explanation that you'd write out on a test. You're justifying why it does not exist, or either find the limit or justify how it doesn't exist, that kind of thing. That's the idea here. Because you're jumping back and forth between two values, you say it doesn't exist. Okay? And those are your three criteria where limits fail to exist. Either it approaches a different value from the right as it does from the left, it increases or decreases without bound, in other words, it's asymptotic around there. Or it oscillates between two fixed values as you get closer and closer to your value, C, as you approach C. Those are the ones that do not exist. Does that make sense? Okay. Some rules for these things. And these aren't too bad overall. It's kind of things, these are the ones that are kind of common sense. Okay? This is saying B and C are both just regular numbers. N is a positive integer. So limit as x approaches like 7 of 12. Well, if I have y equals 12, it's just a straight line. There's nothing weird going on with it. So it's just whatever that number is. If it's actually an identity, well then you're just plugging the value. If it's identity, it's just a straight line. There's nothing weird going on. As long as there's nothing weird going on, you basically just plug in the value. Exponential, there's nowhere an exponential doesn't exist along the x-axis, right? So it's just plug in the value. And same thing for a square root, as long as nothing's negative. If something's negative, it can screw things up a bit because, well, if you do the limit as x approaches negative 2 of the square root of x, well, you can't take the square root of a negative, so it doesn't exist. But as long as everything's positive, n is even, and c is positive, you're good. Okay? Now, this expands then to any scalar multiplier. If you have a scalar multiplier, you can just, assuming a limit exists at all. So limit as x approaches c for f gives you L, limit as x approaches c for g gives you k. As long as these limits exist, then you can multiply them times whatever you want. It's the same thing as if you took that times the limit that you found. Add up the two different limits, the two different functions you know. It's the same thing as adding the limits. Multiplying two functions, same as multiplying limits. Dividing them, same thing as dividing them. Taking the raised to a power is the same thing as taking that limit raised to the same power. As long as the limit exists, as long as it's not breaking one of those three rules, then you can perform all your basic operations on them. Does that make sense? Okay. So, stuff like this, things end up very, very easy with, as long as you realize there's nothing weird going on. What would the limit be of x to the third as x approaches 2? 8. Because you're going to plug in 2 to the third gives you 8. What about the limit of 8x as x approaches 4? 32. What about the limit as x approaches 16 of the fourth root of x? 2. What about the limit of tangent of x as x approaches 3 pi over 4? Which is, without the calculator, -1. 3 pi over 4 is right here, right? What's tangent there? -1. Easy enough? Okay. Almost done. If your function, instead of being a really basic linear exponential, if it's a polynomial. Now, polynomial just means the thing's going to be fairly curvy. It could be x to the third, x to the fourth, x to the 12th. Are there any natural gaps in a polynomial? No. So because there's no natural gaps in the polynomial, no asymptotes, no holes, it doesn't do any weird oscillation thing, that means you can actually just plug in the value. If you want to find what the limit is, just plug in C. For rational functions, you got to be a little bit careful. There might be something weird going on that you got to work with a little bit. If this denominator would be equal 0. As long as it doesn't equal 0, for those fractions, as long as the denominator doesn't equal 0, you can just plug in the value. Okay, if it does equal 0, that's where you got to graph it and kind of work your way to it, either with the table or with trace or something. Or look what's going on at approaching 3, look at 2.999, look at 3.001. Okay? As long as whatever your C value is, isn't going to make this 0, just plug it in. So, what would I do for the first one there? Yeah, it's a regular polynomial. It's a parabola, right? There's no weird gaps in it. You're not dividing by anything. There's no weird square roots to deal with. So, just plug in your value. So I have 2 squared plus 5 times 2 plus 4 gives me what? 18. There's your answer. What about for the next one? Yeah, 2 plugging in the bottom is not going to be a problem because it's not going to give me 0. What does it give me on the bottom? What do I have on top? 18. It's the same as the problem we just did. So in other words, your limit is 3. Questions on any of it? Okay, the rest of the time is yours. Make use of it.